Zen 5, also known as Nirvana, represents AMD's CPU microarchitecture, introduced in May 2022 and subsequently released for mobile and desktop platforms in July 2024 and August 2024, respectively. Serving as the successor to Zen 4, Zen 5 currently operates on TSMC's N4P process, but is slated for transition to the N3E process down the line. This microarchitecture drives various processor series, including the Ryzen 9000 for desktops, codenamed Granite Ridge, EPYC 9005 for servers, codenamed Turin, and Ryzen AI 300 for thin and light mobile devices, codenamed Strix Point. Notably, Zen 5 was first officially acknowledged during AMD's Ryzen processors. 1 year later event in April 2018 and AMD's Financial Analyst Day in June 2022 confirmed the forthcoming launch of Zen 5 and Zen 5C in 3nm and 4nm variants by 2024. The architectural enhancements within Zen 5 encompass a wider front end, increased floating point performance, and enhanced branch prediction accuracy. Moreover, early insights into Zen 5 hinted at integrated AI and machine learning optimizations. In terms of fabrication, AMD strategically designed Zen 5 to be compatible with both 4nm and 3nm processes, acting as a contingency plan against potential production setbacks at TSMC. The architecture's core complex dies, CCDs, are crafted on TSMC's N4X node to facilitate higher frequencies suited for high-performance computing, in contrast to the power-efficient N4P node used for Zen 4-based mobile processors. The Zen 5 CCD, known as Eldora, exhibits increased transistor density and reduced die size compared to its Zen 4 predecessor. Simultaneously, Zen 5's monolithic die for mobile processors, produced on the N4P node, features a diminished L3 cache, but boasts enhanced transistor count and performance metrics. Zen 5's branch prediction system represents a major departure from previous Zen microarchitectures, as it allows for 2-ahead operation, enabling the prediction of up to 2 branches per clock cycle. This advancement contrasts with older architectures that were limited to predicting just 1 branch instruction per cycle, constraining the instruction fetch throughput of programs with extensive branching. Academic discourse on 2-ahead branch prediction dates back to 1996, with AMD's Zen 5 being the first to fully incorporate this concept after 28 years. The execution engines in Zen 5 showcase enhancements, with 6 arithmetic logic units, ALUs, as opposed to the 4 in earlier Zen designs. This increase in ALUs dedicated to common integer operations can result in a 50% boost in scalar integer throughput per cycle. The vector engine of Zen 5 boasts 4 floating point pipes, up from 3 in Zen 4, with an expanded 512-bit floating point data path for AVX 512 instructions. Notably, the AVX 512 capabilities in Zen 5 offer configurable data path widths, with variations in products like the Ryzen 9000 series desktop processors and EPYC 9005 server processors featuring a full 512-bit data path, while Ryzen AI 300 mobile processors employ a 256-bit data path for reduced power consumption. Extensions to AVX 512 instructions include VNNI VEX instructions, catering to increased bfloat16 throughput beneficial for AI workloads. The wider front end of the Zen 5 architecture requires larger caches and increased memory bandwidth to maintain efficient data delivery to the cores. The L1 cache per core has increased from 64 kilobytes to 80 kilobytes. The L1 data cache has been boosted from 32 kilobytes to 48 kilobytes. The bandwidth for 512-bit floating point unit pipes in the L1 data cache has doubled. Its associativity has been increased from 8-way to 12-way to accommodate the larger size. Similarly, the L2 cache retains its 1 megabyte size but sees an increase in associativity from 8-way to 16-way, coupled with a doubled cache bandwidth of 64 bytes per clock. The L3 cache of Zen 5 has also undergone improvements with reduced access latency by 3.5 cycles and a Zen 5 core complex die, CTCD, containing 32 MB of L3 cache shared among the 8 cores. The implementation of Zen 5 3D V-cache CCDs introduces a unique arrangement where 64 megabytes of additional L3 cache is positioned under the cores, resulting in a total of 96 megabytes, allowing for augmented core frequencies and overclocking capabilities. Additionally, the Ryzen AI 300 APUs, codenamed Strix Point, incorporate 24 megabytes of total L3 cache, partitioned into two separate cache arrays, with 16 megabytes dedicated to the 4 Zen 5 cores and 8 MB shared by the 8 Zen 5C cores. Notably, Zen 5C cores are segregated from the 16 megabytes L3 cache array, showcasing a distinct cache access arrangement from the other core type. The enhancements in cache sizes, associativity, and bandwidth across L1, L2, and L3 caches in Zen 5 underscore the architecture's focus on improving data handling efficiency and performance. The Zen 5 architecture introduces various enhancements and updates compared to Zen 4. Notably, it now supports faster memory speeds, with official support for DDR5 5600 and LPDDR5X 7500, an improvement from DDR5 5200. In terms of specific capabilities, Zen 5 offers enhanced attributes such as larger L1, L2 BTB sizes, increased return address stack, more extensive ITLB levels, higher fetched decoded instruction bytes per cycle, upgraded opcache associativity and bandwidth, as well as improved dispatch and scheduler capacities for various operations, including ALU, AGU, and vector operations. Additionally, Zen 5 introduces advancements in the handling of floating point operations, memory pipelining, and retirement queue capacities. In the realm of product releases, AMD unveiled a range of Ryzen 9000 processors based on the Zen 5 architecture, with models including Ryzen 5, Ryzen 7, and Ryzen 9. These processors, manufactured using a 4nm process, exhibit core counts ranging from 6 to 16 cores. The initial lineup of Ryzen 9000 processors was announced in June 2024, followed by their release in August 2024. Subsequently, in May 2025, AMD expanded the Ryzen 9000 series by introducing processors under the EPYC brand, such as the 4585PX, 4565P, 4345P, and 4245P, each corresponding to specific Ryzen 9000 models with varying core configurations. The Ryzen 9000 desktop CPUs share common features including compatibility with the AM5 socket, DDR5 5600 dual-channel memory support, and integrated RDNA2 GPU with specified core units and clock speeds. Each Ryzen 9000 model offers distinct core configurations, cache sizes, and thermal design power, TDP requirements, catering to different performance needs and price points within the desktop CPU market segment. Furthermore, AMD introduced the Threadripper 9000 series processors at Computex 2025, showcasing high-end desktop offerings equipped with Zen 5 cores. These processors, succeeding the Zen 4 Storm Peak lineup, are available in Threadripper and Threadripper PRO variants. The Threadripper CPUs support DDR5 6400 in quad-channel mode, while the Threadripper PRO CPUs offer octa-channel DDR5 6400 support with ECC capabilities, targeting workstation environments with higher memory and PCIe lane demands. The Threadripper 9000 models feature substantial core counts, significant L3 cache capacities, and PCIe lane configurations tailored for advanced computing and content creation workflows. The Ryzen AI 300 series, named Strix Point and Kraken Point, was introduced on June 3, 2024, boasting a new model numbering system akin to Intel's Core and Core Ultra models. Strix Point showcases a third-gen Ryzen AI engine powered by XDNA2, enabling up to 50 TOPS of NPU performance. Additionally, the integrated graphics has been enhanced to RDNA 3.5, with top-tier models sporting 16 CUs of GPU and 12 CPU cores, a leap from the prior generation's maximum of 8 CPU cores. These cutting-edge processors became available in notebooks on July 17, 2024. Common features across the Ryzen AI 300 notebook APUs include a BGA socket, FP8 package type, support for DDR5 5600 or LPDDR5X 8000 in dual-channel mode, 16 PCIe 4.0 lanes, 2 USB 440 gigabits per second, and 2 USB 3.2 Gen 210 gigabits per second ports. The integrated GPU leverages the RDNA 3.5 microarchitecture, while the neural processing unit utilizes the XDNA 2 AI engine. Both Zen 5 and Zen 5C cores are geared for AVX 512, with a half-width 256-bit floating point unit, accompanied by an 80 kilobyte L1 cache and 1 megabyte L2 cache per core. Production is done through the TSMC N4P FinFET process. One notable model, the Ryzen AI Max Plus, in parentheses PRO 395, features 16 cores, 32 threads, a base clock of 3.0 GHz, a boost clock of 5.1 GHz, 64 megabytes L3 cache, an 8060S model GPU with 40 CUS, and a hefty TDP ranging from 45 to 120 watts, expected in the first quarter of 2025. The Ryzen 9000 Fire Range series includes features such as an FL1 socket. It supports dual-channel DDR5 5600 memory up to 96 gigabytes. There are 28 PCI 5.0 lanes. The series offers 4 native USB 3.2 Gen 2 ports with speeds of 10 gigabits per second and 1 USB 2.0 port with speeds of 480 megabits per second. Additionally, it includes an AMD Radeon 610 integrated graphics processing unit. Manufacturing is done using TSMC N4 FinFET for the CPU core dies and TSMC N6 FinFET for the input-output dies. An example from this series is the Ryzen 99955HX3D. It features 16 cores and 32 threads. The base clock speed is 2.3 GHz, and the boost clock speed is 5.4 GHz. It has a large L3 cache of 128 megabytes. The processor is packaged with 2 CCDs and an IOD unit. It has a power rating of 54 watts. This processor is expected to be released in the first half of the year 2025. Joining forces with Granite Ridge desktop and Strix Point mobile processors, the EPYC 9005 series of server processors, codenamed Turin, were unveiled at Computex on June 3, 2024. Utilizing the SP5 socket like its predecessor EPYC 9004 series, the top-tier Turin model is designed with up to 128 cores and 256 threads, constructed on a TSMC 4nm process. The EPYC 9000 server processors, including models like the EPYC 9755, recommend DDR5 6400 in 12-channel mode for seamless functionality. The fabrication is handled by TSMC N4X, channeled through a variety of configurations denoting core count, clock rates, L3 cache size, TDP, and more, catering to diverse performance needs in the market.